Hello, and welcome to the Poor Man's Chemist. This is the third video in our series of From Bismuth to Bismuthate, in which we will be doing the synthesis of sodium bismuthate from bismuth trioxide, sodium hydroxide, and elemental bromine. I have posted a copy of the synthesis down in the description, and we are going to be scaling this synthesis back a little bit because I only had so much bismuth metal and could only make so much bismuth oxide. The original synthesis calls for 170 grams of bismuth trioxide, but I've got 60. I have more than enough bromine to do the synthesis with that, so everything has been scaled back to fit with that 60 grams of starting material. Alright, so what I have here is our 40% sodium hydroxide. It is supposed to get to the point where it's boiling. It's almost there. So now that that's there, I am going to go ahead and add in the 60 grams of bismuth trioxide. Actually, probably should get a funnel, that might help. So we're going to add this in and let it stir until it gets to the point where it is actually boiling. And then we will go ahead and begin the addition of the bromine. Alright, we finally got to the point where it's boiling. It was boiling a bit more vigorously just a second ago before I pulled the foil off of it, but I figured it would be better for y'all to actually be able to see this step. So now what we're going to do is add 105.77 grams of elemental bromine to this flask. This reaction is very vigorous. It tends to splatter all over the place. That's why I'm actually doing this in one of these tall flasks. The biggest flask that I have is a sidearm Erlenmeyer. That's why it's a sidearm. That's the only reason. Otherwise, it would just be a regular flask. But you'll see in a second why I wanted to use something that was large and that was curved inward to catch any splashing liquids. So I know it's going to cool it off a little bit if I turn on the fan here. Let's see if I can do this without just this one going. Alright. Let the games begin. Let's see what I mean. Vigorous and violent. Cap on, let it stir, and let all that bromine dissolve into the liquid here. Turn the stirring up at this point. And yes, it is all going to be like that. This is a ridiculously dangerous synthesis. You probably could use an addition funnel and a flask that's designed to hold it, and you could do it that way, but where's the fun in that? Okay. I have found that if you let it dribble down the sides, it tends to be a little better. And if you watched the bromine synthesis video, you will know that thiosulfate is your friend when you're working with bromine. That is also true here. Of course, whatever you do in a boiling flask, do not tightly cap it. That would be bad. Come on. Stir. Please. Yow. Yeah, it looks like one fan is working pretty good. And you can see once it gets going, it does not take long for the bromine vapor to clear up. So the reaction gets going pretty decently. Come on, stir bar. Okay, we've got about 18 grams of bromine so far. Only 70 something more to go. Whoa! And that's why you don't want to go too fast. Yeah, it definitely gets hotter as it goes. Probably turn the heat down just a little bit here. Last thing we want is for this thing to suddenly decide it wants to boil up out of there. That would also be bad. Okay, don't be evil. On the other hand, you got to get it in there somewhat quickly. Otherwise, it's all going to just boil on out of there and you'll lose all the bromine. Yow! Alright, we're going to let that stir for a minute and cool off a little bit. We don't want it to stop boiling, but a little cooler than this might be good. One nice thing about the sidearm is it makes it easy to pick this thing up. Alright, yes, the stir bar started working again. Small wonders never cease. Okay. Time to go for maximum redneck fume hoodage. Alright, how much have we used thus far? 40 grams. Still got a ways to go. Although I guess one good thing about using a sidearm for this is that it equilibrates the pressure. You're less likely to have a catastrophic boil over. Okay, that works a little better. Just drop it down into the center of the vortex created by the stir bar. That works nicely. Distributes the heat much better as well. Okay, I think this pipette is giving up the ghost. Alright. Okay, we've got 70 grams in there so far. We're getting there. We have a 35 to go. Yeah, this is a much better way to do it. Less splattering, less waste, less vapor. And I'm not even squeezing the pipette. It's just coming all out on its own. Oh, shit! I told you all before, this is why you keep your bucket of thiosulfate around when you're working with bromine. So that if you get a little droplet of it on you, it's not a crisis. You just get it off with the thiosulfate and everything's fine. It absolutely burns like hell though. Cannot stress enough just how much it hurts to get this crap on you. It's not like acid where you know, have a delay from when it hits you to the onset of the burning. With bromine, there is no delay. The burning pretty much starts immediately. And I would point out too that you don't just touch it with a little thiosulfate solution and it's just all better. No, no. You know, like dip a cloth into the solution and wipe off the spot. May not all go away on the first time. I have to wipe it off a couple times, but it will go away. The one thing you don't want to do is, you know, freak out. But then, of course, none of y'all are doing this at home, so, you know. Since this is only happening in professional labs, I'm sure you've got showers right there that you can use. Alright, 85 grams, 20 more to go. Come on, wrapped already. Let's go. Alright, the reaction is starting to slow down a little bit. And that could be because it's cooled off a little. Okay, 103 grams of bromine. We're almost there. 2 more grams. Alright. Theoretically, that's pretty much got it. Obviously, we have lost some from the vapor, so I'm going to put in just a little bit of excess. Not a lot. Ow. only 2 drops of bromine on me. That's pretty good. Alright. Alright. I have filtered off all of the precipitate. Well, it wasn't really a precipitate. Filtered off all of the whatever was produced in the reaction between the bismuth trioxide and the bromine. I'm not exactly sure what the intermediate would be. But anyway, whatever it is, here it is. And the next step is to filter it with wash it with 40% sodium hydroxide. So we're going to do that here. And then we're just going to let this drain out, and then the next step will be to suspend this in 1058 milliliters of water and agitate it until we get a color change from this brown color to yellow. So as soon as all of this filters on through here, which it looks like it's going to take a little bit, we will come back and we will go ahead and suspend it in the water and record the color change. Alright, so once everything's settled out, you can see that the color is a little lighter than it was. I don't know that I'd call that yellow, but it is lighter than it was. Alright, so I decanted off the liquid that we had in the flask, and then I've added to this 529 mils of 53% sodium hydroxide. The protocol says to let this reflux now for half an hour, so I've just got some kind of slow stirring on here, making up the NaOH. It's already incredibly hot, so it shouldn't take too long for it to start boiling. And yeah, then we'll just let it boil for 30 minutes and then move on to the next step after that. So we're almost done here. We're getting towards the end, so it's looking good. Alright everybody, we are back and this is looking great. Again, I don't know if this will show up well on the video or not, but this is definitely a different color than it was when we started. It's turned back into that more, almost kind of a yellowish brown. But from what I can tell, this is our product, and it actually worked. Of course, we'll still have to test it, but this is it. This should be sodium bismuthate right here in suspension. The next step is to filter it and to dry it. And so I am going to go ahead and turn this off and let things settle for a bit, and then I'm going to go ahead and filter it. Alright, so we have a solution of manganese dichloride, and I think I'm actually going to change the order of things around here. I'm going to go ahead and add some of the sodium bismuthate to it, and then add in the hydrochloric acid. So there's the sodium bismuthate. Here we go. And now, I'm sorry, hydrochloric acid, sulfuric acid. Would you look at that? That purple color looks like a positive test to me. If we keep going, it should start to give off chlorine gas. Yep, that is definitely chlorine. So it oxidized the manganese dichloride to permanganate, And now it is oxidizing the chloride to chlorine. It's pretty cool stuff. So there you have it, people. The synthesis of sodium bismuthate from bismuth metal. That is pretty damn cool. I hope you've enjoyed this video. Please feel free to comment, like, dislike, whatever takes your fancy. And we will see you all in the next video.